So a particle of mass 5 kilograms is pulled along a rough horizontal surface by a horizontal force of 20 newtons. So let's draw our diagram. So there's our rough surface. We have a particle of mass 5 kilograms. It's being pulled along a rough horizontal surface by a horizontal force of magnitude 20 newtons. The coefficient of friction is between the particle and the floor is 0.2. So first let's get our weight, which is 5g. So we write that, 5g. And we have our normal reaction force. Now instead of using F for friction, because we have F equals ma and F we often use as normal forces, instead of writing F, I'm just going to write mu r because my friction is equal to mu r. So, because the particle is moving, mu r is going to be at its maximum. If the particle is not moving, then the friction will not be equal to its maximum. It will be equal to the pulling force, because the forces will be in equilibrium. If the forces are not in equilibrium, then the particle will be moving, and therefore the friction will be at its maximum. So we want to find the magnitude of the frictional force. So we want to find what mu r is equal to. So it's useful to recognize that we have 5g as our weight. So therefore, because r and 5g are in equilibrium, if we think about resolving our forces vertically, r minus 5g is equal to 0. So r equals 5g. Now I'm going to leave it at that for now because I'm not particularly interested in that. I'm more interested in my frictional force. So mu r therefore is going to equal to, because mu is 0.2, this is 0.2 r. So mu r is going to be 0.2 times by 5g, which is just going to equal g, or 9.8 newtons. And that's A. For B, the acceleration of the particle, now we need to resolve our forces horizontally along the horizontal plane. So when we do that, we have 20. So if it's accelerating, we know we're accelerating in the direction that the object is being pulled. Friction can't make it accelerate the other way. It resists motion. So if we resolve forces this way, 20 minus our friction, minus 9.8, will equal our mass, which is 5, multiplied by our acceleration. So 10.2 equals 5a, which implies my acceleration is equal to, we can do 10.2 divided by 5, sorry. Let's get 2.04 meters per second squared in total.